Yes.
Yes, sir.
Okay. So today we are going to start about the downcasting in Java. To understand this downcasting, we had to understand about the instance of operator, right? Which was discussed yesterday. So why one has to, what are the benefits of instance of operator that has been understood yesterday, I believe, completely. Right? So with this, we can focus on understanding this downcasting mechanism. So we know what is upcasting. We have to understand what is downcasting. Simply, I can say that it is a process of converting if you create an object for the superclass, right? And if you are trying to assign the object to the subclass, okay, then it is called as what? It is called as downcasting. So this process is called as downcasting. So what do you really mean is like, let us say that I have a class here. I have the class. I have two classes. My class B is extending to A. So we know the object creations, right? You can create an object for the class A. You can create an object for the class B. It is like object is created for the class A, and you can assign it to a reference variable which is of A type. A parent reference, parent object. The second case is you can take a reference variable and you can keep the type of the reference variable as B. So child object, the type is also child. Okay. What is the third case that we have discussed? The third case would be like you create an object for the child class and you keep the parent type as the reference. So this is called as upcasting. Right? And what is a downcasting? Create an object for the parent class or superclass. A is the parent class. In our example, class A is the parent class, or I can say it as superclass. And if you are trying to take a reference variable of type B, right? This process is called as downcasting. Unfortunately, downcasting, the implicit downcasting, it is not possible in Java. When I say downcasting, this is what it means. Means you create an object for the parent class, but the reference variable is going to be of child class. Right? So this is possible, this is possible, this is also possible. However, this is not possible. Unfortunately, this is not possible. Why it is not possible, that we are going to discuss it, and how you can make it possible, that also we will be discussing in the today's class. Right? So let me put a small theory. So what is a downcasting? I can say that it is a mechanism. Downcasting is a mechanism of uh, converting. Mechanism of converting a reference or else I can say the mechanism of assigning the object of the parent class to the child class. The child class type. Right? So this is called as what? Downcasting. This is called as downcasting. Right? This is the example. So if you take two classes, class A and class B, and there is a relationship. So this is one way of creating an object. You can create an object like this, and also you can create an object like this. The third way of creating object is create an object for the child class and assign it to the assign it to a reference variable of parent type. Upcasting possible. Okay, but when you try to create an object for the parent class, right, and assigning it to a reference variable of child type, this is called as downcasting. Unfortunately, it is not possible in Java. We are going to understand how we can make it possible first thing. So this is the actual definition. The definition is very clear so far. Let me give you a small example. Okay, to understand this, I will be taking a simple example. Okay, and let me use this driver class itself. Let me remove all this. Okay, let me say that I have a class A, I have class B. Okay, my class B is extended into class A, right? So class A is going to have some properties. Is going to have some methods or behaviors, right? Behaviors. Likewise, class B is going to have some properties and behaviors. Behaviors are nothing but methods. So when I say A obj equal to mu A, okay? So with the help of this reference variable, okay, in my example, the reference variable is obj. I can able to access all the properties and behaviors of class A. All the properties and behaviors of class A. So this is very clear. Second one is when I create an object for the class P. Okay. So by using this reference variable, I will be able to access all the properties and behaviors of both class A and class B. Both class A and since it is a child class, right? So you have access to the properties and behaviors of the child class, and you have made a relationship, right? So because of this extends keyword, there is a relationship. There is a relationship between class B and class A, and you have rights to access the properties of behaviors of the parent class also, right? What is the third way? Third way is like A obj 2 equal to new B. Okay. So with the help of obj2 reference variable, I can able to access all the properties and behaviors of parent class. Okay, behaviors of class A, and with the same methods, are available in class B, they could be accessed. Right? We have discussed this. These are the things which has been discussed in the previous classes itself. Okay? Now the point here is, I want to do what? I want to do something like this. Can I focus here? Let me say that I am creating an object for the class. So this is the object creation. Okay? Object has been directly created for the class, right? And what I want to do now, I want to say, I just want to assign this object. I just want to assign this object to something like obj3 or obj3 2b. Right? So this is called as what? This is called as explicit typecasting or downcasting explicitly. Down explicit. Let us see what we are going to get if I just run this code. Okay. Let me use the command prompt java c space driver.java. It says you are getting an error. Incompatible type A cannot be converted to B. Okay, you are saying that object is created for the class A. So always observe this. Okay, this class A is of parent type or the class A is of superclass type. You are assigning the object that is created for the superclass type to the subclass type. So this is what the down, you are casting it down, okay, which is not supported by Java first of all. Okay, this concept is called as downcasting, which is not supported by Java. You will get what? You will directly get the compile time error. This is not even accepted, right? So when you get this kind of code in your interview room, you will have to say that the downcasting is not possible in Java. Okay, because Java does not support the downcasting. First question. Please be informed that downcasting is not possible in Java because Java does not support downcasting. Okay. Now I am going to introduce three cases. The case one. Okay, what I'm trying to do, I want to ensure that I am able to do the downcasting also. I just want to ensure that. I just want to ensure I am able to do the downcasting also. What are the possible things that I can do? You go back to the code. Now you see. Now see what are the possible things that we can do so that the downcasting is possible. Let me remove all this. Okay. Now let us focus only about these three classes. Okay, you have class A, you have class B, and you have the driver class. What I'm trying to do here is, let me create an object for the class A, which is new year. This is completely valid, right? Because parent type and object is created for the parent, so both are parent. It is completely possible. I'm just trying to do a kind of magic here. What kind of magic I'm going to do? I'm taking this reference variable, and I'm assigning this reference variable to some other reference variable which is p of type. Okay. Ideally, this is also called as what? This is a downcasting, but you don't see the downcasting is actually happening. If you just, unless and until if you just replace the actual reference variable, actual value of the reference variable A. What is the actual value of the reference variable A? Okay, you have new A. Right? It is same like you're doing the downcasting. It is same like you're doing the downcasting. So I'm doing it in a different way. What I'm trying to say, I'm taking the reference variable of the parent type, okay, parent type, and I'm assigning it to reference variable of the reference variable which is of the subtype, which is of the child type or the subtype. This is also called as downcasting. What happens if I do this? This is a case study. So what happens if I do this? So you get compile time error. You know this point. The case one. Case one. Please be informed that if you take the reference variable of the parent class type, assign it to the reference variable is of subclass type, you will get compile time error because it says that the downcasting is an indirect downcasting. It is not possible in Java. So you get this compile time error. Okay, you will get this compile time error. Let me take the case 2. Case 2. In the case 2, I am going to do a similar kind of changes. Okay, but this time what I am trying to do is, so I will be like going to the same class. I will be going to the same class. Instead of doing this, by doing this, we are getting the compile time error. Okay, instead of doing this, I want to do some other thing. I am saying I am just doing the same thing, but I am using the typecast operator. Right? I am taking the reference variable A. Okay, I am taking this reference variable. I am assigning it to a different reference variable. okay, which is of type A. Okay, so this A is nothing but replace this A with new A, which means indirectly downcasting is happening. At the same time, I am using the cast operator. I'm using the cast operator. Okay, this is also a kind of downcasting, but this time, okay, instead of keeping it directly, keeping the downcasting directly, I am just casting it down again. I'm just casting it down again. If I'm taking this, I'm saying that cast it down to the type B. Okay, so that the RHS side is going to be balancing the LHS side. Okay, even though the reference variable A is of this A is what? This A is mu A. Right? Given the reference variable is of the age of A object, I'm just typecasting it to B and I'm assigning it to the B type itself, so that there is a balance here, right? RHS side is equal to becomes LHS side. Well, this is allowed or not, we will check. Okay, let me try to compile this and execute this. Java C space driver.java. It's taking some time. Okay, compilation is successful. Java space. Okay, now you are getting the runtime error. You are getting the runtime exception in the runtime. Okay, what is that? It says java.lang.class cast exception. A cannot be cast to B. Okay, we are trying to do the conversion. Okay, we are just trying to do a kind of conversion. You have the A, right? You are converting that A to the B type. Okay, you are forcefully casting it down. You are forcefully doing what? You are forcefully casting it down to what type? This parent type is being casted down to the child type. You don't get any confusion. Let me take it to the plain screen. Okay, so this is the actual object that I'm going to use for the downcasting. Okay, A equal to new A, right? So in this example, this is completely valid. Okay, the type is A and the object is also created for the A. Okay, what is the first case that I have taken? The first case, instead of using new A, okay, I'm going to use this reference variable A. I'm trying to use a reference variable A. If I ask you what is this reference variable A, what value this reference variable has, the value it is storing is new A. It is storing the object value, right? I'm assigning this reference variable to a different reference variable P, which is of type A. Okay, this is one way of downcasting. So this is same like, okay, this is same like B equal to new A. Because A is holding the value new A. Both are same. In the beginning itself I said, so this concept is called as, so just try to do the comparison. Okay, the object is of parent type. Okay, but the reference variable is of what? The type is of child type. A parent object cannot be assigned to the child type. So this concept is downcasting, which is completely invalid. So when you do this, you will get what? You will get compile time error. Okay, what is the second way that I'm going to do? Second way also I'm trying to do the same things in the second case also. Like B equal to A, but this time I'm using the typecast operator. I'm trying to use the typecast operator and I'm forcefully downcasting. I'm forcefully downcasting this A type to the B type. Okay, so because of this, I'm not getting any compile time error. No compile time error. No compile time. But I'm getting the error at the runtime. So compiler is ignoring this error because it blindly thinks that okay, we just did the typecast operator. It assumes that this is valid. But in the runtime, we are getting this error. No compile time error, but rather is a runtime error at the time of execution. The main thread finds it. Okay. What error we are getting? We are getting the class cast exception error. We're getting what? Class cast exception. Okay, second case is also fail. Okay. So one case has to pass. That case is called as what? The third case. Okay, what is the case two? When you are creating an object of A equal to new A. right? You are trying to do what? You are trying to do the forceful downcasting with the help of typecast operator, right? And I can say that please be informed that if a reference variable of parent class type is forcefully typecasted, child class type using the cast operator, in the typecast operator, there will be a runtime error as follows. Okay, what is a runtime error? So this is the runtime error. Right now the case 3. Now the case 3 is the interesting case where we can make it possible, where we can make that the downcasting is actually possible. If the case 3 says instead of doing all these things, you can go with some other thing. Right? So we can able to achieve the typecasting with the help of case 3. So what I'm trying to do here is go back to the code. Right? Okay, now I am creating an object for a equal to new. Okay. Now I have the object created for class B, but the reference variable is A. Reference variable is of A type. Object is created for B type or the child type. Reference variable is created for, it has been assigned to a reference variable which is of parent. If parent equal to E equal to C, which is possible, and literally, technically we call this what we call it as upcasting. Right? Now what I'm trying to do, I'm using this reference variable here. I'm using this reference variable. I'm typecasting this reference variable to B type. Okay, and I'm assigning it to what? I am assigning it to a reference variable, which is what? Which is of B type itself. Let us see whether this is possible or not. Java C space driver.java. Java space driver. Okay, now there is no compile time error, there is no runtime error. The downcasting has been achieved successfully. The third case says whenever an object is created, case 3. Okay, please be informed that if a reference variable of child class the reference variable of child class object is typecasted and assigned to the child class object itself. Child class type itself. Then there will be no compilation error and runtime error. In this way, the downcasting can be achieved. Now, what are the advantages of doing this downcasting? To understand this, let me take a small example. So yesterday we were discussing, no? we're discussing like we have discussed about the animal class. Okay, let me take the animal class. So let me take the three other classes. One is the dog class, and the second one is the cat class. Okay, and the third one is something like let me take lion class. Right. So in the animal class, I'm going to take the common method. So the common method would be like this. Okay, make I mean eat method. Right. I want to print something like system dot out dot println. Okay, every animal is. Okay. So in the dog class, in the cat class, and in the lion class, I'm going to take something like make noise method. Okay. Make noise method. Okay, this is make noise method of cat. Okay, this is make noise method of lion. Okay, so in the parent class, I have only one method, which is the eat method. But in the child class, I have these many methods. Okay, now let me remove this code inside the main method. Right, I want to make a relationship. What kind of relationship is a relationship? The lion is also extending to animal. Okay, the cat is also extending to animal. Okay, and the dog is also extending to animal. Okay, this hierarchy is going to be like it is going to look like this. Okay, I have the animal as the parent, which is the common class, and I have three subclasses. Okay, one is the dog class, and second one is you have the cat class. The third one is what lion class. Okay, dog, cat, lion. Okay. For the dog, the parent is animal. For the cat, the parent is animal. For the lion, the parent is animal. Okay, this is representing hierarchical inheritance. Okay, so what is the common method? What is the common method that I have in animal class? I have the eat method as a common method in the animal class. So only I have the eat method. Okay, and what is the specific methods that I have in the dog class? In the dog class, I have the make noise method, is specific to dog. Okay, I have the specific. I mean, I have a method which has a specific implementation to its subclasses. Make noise method is there in cat class, and make noise method is also there in lion class. Lion class. Okay. Now you see, I have an option to create objects for this particular Java code in three ways. I can either do this. Okay. When I do this, when I say a obj equal to new a, with the help of obj reference variable, I can access only all the methods of what class, all the methods of parent class I can access. If you say, I can only access the eat method. But whenever I create an object for any one of the subclasses, so for example, I may create an object for dog or cat or lion. Let us say I'm creating an object for the dog class. Okay, whenever the object is created for the dog class, so this is how dog d equal to new dog. Right? Now I can say with the help of this reference variable, I can access all the method of the dog class, which is what make noise is the only method that is there in the dog class. Okay, and I can also access the all the methods of the parent class, which is the parent to dog. Animal is the parent to dog, right? So I have also access to the eat method of animal class. Okay, so I can also access eat method. Okay, second. Okay, and one more thing I am going to take. So let me say I am taking a common method like void run method. Okay. So this run method is common to both common to animal as well as all the subclasses. Okay, there is a run method in dog class, there is a run method in cat class, there is a run method in lion class. Okay, run method is there in all the classes. Okay, under the dog, under the animal, in the animal class run method, okay, I'm going to print something like animal runs. Okay, under each and every implementation subclasses, I'm going to have implementation like dog runs. Okay, cat runs. Okay, lion runs. Let me add these methods. You just see the representation. I have the eat method. I also have the run method. The run method is part of animal class and it is also part of all the remaining subclasses. So there is a run method here. There is a run method here. There is a run method here. Okay. So this is one of the way to, this is the parent object creation, child object creation. Right. So I can also have an option to create an object for what? Upcasting. I can say animal c equal to new, let me say new cat. Okay, this is just like representing parent reference variable and object is created for the child class. Right. So with the help of reference variable C, what are the methods that I can access? I can access all the all the methods of parent class and the overridden methods of the child class. Right. So I'm talking about the animal and the cat here. I'm talking about the animal and cat. Let me change the color. Now I'm talking about the animal and the cat. But if you see, with the help of reference variable C, I can access the eat method, which is of animal class. Eat method of animal class. I can access this. I can access this. Okay. I can access the run method, but this time when I say run method, this time when I say run method, finished up this one. It is not respond. Okay, let it be. I will explain from the notepad soon. Okay, I have separated this classes in this particular class into two parts. Okay, so how many class that do we have? We have the animal class, right? Second one is we have the dog class, which is extending to animal. Third one is we have the cat class, which is extending to animal, right? And we have the lion class, which is also extending to animal. So there is an hierarchical relationship. At last, you have the driver class, which is holding the main. Totally, you have five. You are dealing with how many classes? You are dealing with almost five classes, right? So the moment I start creating for the object like okay, animal obj equal to new dog or whatever, new dog or cat. Okay, when I say new dog, so just try to observe whether the object is created for parent class or child class. So in this case, dog is the child of animal, right? I can say that okay, the type is parent and the object is created for the child. So this is representing what? This is representing upcasting. Now we are trying to understand what are the benefits of downcasting. So it's not about I'm talking about upcasting. We are trying to understand what are the benefits of about upcast. I mean about downcasting. With the help of reference variable obj, right, I can access all the methods of the A type. I can access all the methods of A type. So go to the animal class. What are the methods that I have in the A type? Okay, I can access the eat method. Right, this is very specific to the animal class. Okay, I can access the run method. Okay, but this run method is common to the child class also. This run method is available in the parent class as well as child class. The priority will be given for the child class. So these will get executed and this method will get executed. Right, with the help of obj, I can access the two methods. One is the specific methods inside the class, the parent class, which is eat method. The second thing is the common methods inside the both class and the priority will be given to the children class. So you have run method here, you have run method also here. Okay, the priority will be given to the child class. So you get access to the run method of child class. C class. Okay. But I also want to get the method. I also want to get the access to the make noise method of the child class. I'm interested to get access to the make noise method of the child class by using the reference variable obj. I do not want to change my reference variable. With the help of this reference variable, okay, with the help of this, I want access to the make noise method. So this is the method that I'm interested to access. Okay. So what can I do? I can just do the downcasting. So take the operator obj and take the reference variable obj here. Okay. Cast it down to the child type, which is what? Which is dog. Okay. And assign it to a reference variable, which is also the dog. So we have achieved the downcast. Right? After casting it down, after doing the downcasting, with the help of this reference variable, I can access the make noise method. Okay, now I get the output as this will be printed in the console. So this is the advantage that you have in the downcasting. Okay, this can be understood very simply by just do a small change. Let me say that I am creating an object for the animal A equal to animal A1 equal to new dog. Okay, animal A2 equal to new cat. Okay, animal A3 equal to new lion. Three objects has been created. So I'm going to do a kind of conditional checking. Okay, if A1 if A1 instance of dog, okay, if A1 is instance of dog, I want to cast it down. I want to do what? I want to cast it down. I want to cast it down to the dog type. Okay, and assign it to the dog's reference variable. Okay. And with the help of this reference variable, I want to execute the make noise method. Okay. Else if, let me do, let me remove all these things. Else if I want to do something here. If a1 is instead of dog, I want to do this. If a1 is instance of cat, okay, I want to do this. Okay. If not, in the last I want to do this. Okay, now you say, if I just pass the reference, if I just create an object for the dog class and I assign it to the animal type, okay, the respective the specific method of the dog class will be printed. The make noise method will be printed. It says, so likewise in the runtime, instead of dog, if I pass cat here, okay, the specific method of the make noise method of the cat class will be executed. Okay, likewise, if I pass the lion, okay, the make noise method of the lion class will be executed. So let me take this code. Okay. Okay. So here, okay, you can take the reference variable animal a1 equal to, right? You want, you can pass any of the subclasses. Okay, animal is parent to what? Animal is parent class to the the dog object, the cat object, and the lion object. The animal is a parent to all these objects. You have the dog object, you have the cat object, and you have the lion object. Right? And if you see these three these three classes, okay, these three subclasses have the very common method, which is what, which is the make noise method. The make noise method is common to dog, but it has its own logic. Make noise method is common to cat, it has its own logic. Make noise method is common to lion, it has the own logic. It has its own logic, right? So what you're trying to do in the runtime, if you just pass new dog, right, and you just typecast it, okay, if you are just typecasting this reference variable, you're checking here, okay, whether the object is of you are checking whether if it is of dog type. Okay, you are doing the downcasting and you are executing the specific method of the dog class, which is make noise. Okay. Likewise, if you are passing the cat object in the runtime instead of dog, if you are passing the cat object in the runtime, right? So there is a check-in. It will check whether if it is, if A1 is instance of cat. If it is instance of cat, you first downcast it. The advantages of downcasting is that you can call the specific method of the children class. Specific method of the child class. Make noise method. Likewise, in the runtime, if you pass the lion object, okay, and you can downcast it. Okay, so there is a conditional check is happening in here, like an hierarchy. You are using if else conditional check. Okay, every time you are checking whether this particular A1 is instance of dog or instance of cat or instance of lion or instance of lion. At least one will be matching at any point of time. Depends upon the what kind of object that you are passing in the runtime. Right? So you are just trying to check in the runtime whether it is a dog object or the cat object or the lion object. If any one of the objects are matching, that particular class common method, that particular class specific method has to get executed. So this is the advantages of a downcasting. So why we are going for this downcasting? We know this, right? So animal A can be, I mean, the object of animal can be assigned to the animal type. The object of the subclass can be assigned to the subclass type. So the object of the subclass type can be assigned to the parent class type. Okay. The subcasting, right? So this has an advantages, like all the parent class methods. You can call all the parent class method. Here you can call all the subclass methods as well as the parent class method. Here you can call only the parent class methods, and if the methods are overridden, if the subclass methods are overridden, those methods can be called. Okay, but by using this, what if you want to call the subclass methods also? What if you want to call the subclass method also by using this? By using this, what if you want to specifically call the cat class methods, which cannot be called by using upcasting, but it can be. So this is actually placing the restrictions. Okay, this is placing restrictions to call the specific subclass methods. In this case, make noise methods cannot be called by using this reference variable. In this case, make noise method, you cannot call the make noise method by using the reference variable C. So I want to make it happen. Okay, what I can do, I can downcast it. I can use the reference variable C, which can be downcasted to the subclass type, which is cat. Okay, and I can assign it to what? Assign it to the cat type itself. Okay, now by using this, I can call the specific method of the subclass, which is what? Make noise method. So here there is a restriction. Here there is a restriction to call make noise method. In the runtime, if you want to make any restrictions, okay, when you create an object like this, restrictions can be placed on the subclass specific methods. If you want to remove those restrictions, okay, you can just downcast it so that you can get access to those subclass specific subclass. So this is an advantage of downcasting, right? And try to do some practice. So by this, downcasting concept is over, and we have only 3 topics left. One is polymorphism, second one is abstraction, okay, and interfaces, and we have arrays. By this, the core Java will be over. and we will can start the process. That's all from my side. If you have any questions, you can